All right, guys, here is a sample confidence interval question. You sampled 500 adult residents of Cook County and asked whether they lived within 1 mile of a park that they felt safe walking in. 350 said they did. Construct a 95% confidence interval for the population proportion of adults of Cook County who live within 1 mile of a safe park. Okay, so I'm going to keep that there so you can write down what you know. Write down all the things that this question tells you and get an idea of what it's asking for. Okay? Okay, so we know there's 500 adult residents. It's going to be n equals 500. The p is going to be 350 over 500. Okay? So here we go. N equals 350. P, no, excuse me, 500. P is the proportion who said, yes, I live within a park. I live within a mile of a safe park. 500. Okay, and that is 0.7. Okay, we know we're going to have to calculate a standard error. We always know that. So we're going to do P, 1 minus P over N. That's going to be the square root of 0.7 times 0.3 over 500. And that's going to be 0.0205. Okay, so that's it. So our 95% confidence interval formula is going to be our point estimate, or the estimate that we made with our sample, 0.7. So our sample told us that 70% of the people lived within a park in Cook County that they felt safe in. But we know we've got a margin of error. So our margin of error is our critical z-value times our standard error. Okay. We go into the z-table. We find that at a 95% confidence interval, we have 5%, we're allowing ourselves basically 5% error, so that's going to be 0.025 in each tail. Right? So we add those up and we get 0.05, which corresponds now to our 95% confidence interval. Okay, so we know that the z here at 0.025 is 1.96. We know our standard error is 0.0205. And what we'll end up with is 0.7 plus or minus 0.04. So now we need to create the interval. 0.7 minus 0.04, which is 0.66. 0.7 plus 0.04, 0.74. Okay, and here is how we would interpret it. I am 95% confident that the actual population proportion of adult residents of Cook County who live within 1 mile of a safe park is between 0.66 and 0.74. And if we go back here, we see all the words that we need to make that sentence work. Okay, so always turn your sentence back, go back to the context of the question and make your sentence work with it. Okay, so there we go. That's the answer. Boop, 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 boop. Now let's do a confidence interval using a continuous variable. And here's the question. You have a sample of 72 light bulbs. So that tells you right now your n is 72. The sample mean duration of life for these light bulbs is 400 hours with a standard deviation of 18. The question wants you to construct a 99% confidence interval of the population mean duration of life for all light bulbs. Okay, so we're going to write down things we know. N equals 72. X bar is going to be 400. S is going to be 18. Okay, so we can go to that now. N equals 72. S equals 18. X bar equals 400. Okay, so x bar is our sample mean. That's what we got. That's the mean we got from the sample. This is the standard deviation of the sample, and this is the n. All right. What do we know about confidence intervals? We know that it's going to be x bar. This is a 99% confidence interval. X bar equals, plus or minus our margin of error, which is going to be t statistic times standard error. Oh, we need the standard error. So we go over here and we write standard error. We know with a continuous variable like this is s over the square root of n, which is going to be 18 over the square root of 72, which then is 2.12. Okay, so we're going to use that up here. Okay, x bar, our estimate of the population proportion that we got from our sample is 400 hours. Our t, well, we go to our t table, and we know that the degrees of freedom here is 72 minus 1 equals 71. So we go to our t table and we look for 99% confidence at degrees of freedom closest to 71. And I get 2.64, and I multiply that times the standard error, which is 2.12. So here's my estimate, and here's my margin of error, 5.60. So now I need to create the confidence interval, which is 400 hours plus 5.60. Okay, so we've got 390, let's just make this 6. Okay, 394 and 406. Okay, so I am 99% confident that the population mean hours of life for light bulbs is between 395 hours and 406 hours. 394 and 406. Okay? 2 questions here. Let's say we doubled the sample size, and instead of 72, we had 144. What's that going to do to this confidence interval? Is it going to make it wider or more narrow? If n were equal to 144, wider or more narrow? Be sure you know how to answer that. Also, what would happen if we change the confidence to 95% instead of 99? Would that make this confidence interval wider or more narrow? Okay, be sure you know the answers to those questions. Alrighty, bye. How do I stop? Stop.